Whoa, whoa, whoa. Okay, looks like my setup is kind of messed up. The video was way shorter than I expected, so we are live. That's great. Welcome, everyone. This is this is the 10th, I think, Tech Talk. Super happy to be back. Today, we have a speaker who actually woke up really early for us, so that's going to be really, really fun. Welcome from wherever you're joining us from. While we gather folks, you kind of know the drill by now. I would love, whether you're joining us from LinkedIn or from YouTube, I would love to hear about where you're joining us from. Just say hi in the chat. It's usually really fun to see people joining us from all over the place, including Belgium. Hello, Luke, joining from LinkedIn. Hello from Pakistan. That's a new one. That's really nice to see. So yeah, we're back from France, as far as I'm concerned. And today's topic is going to be, like I was telling our guest just before, like I think I shared on LinkedIn yesterday. My hope with today's talk is that I will, or maybe I won't, who knows, develop an addiction for mechanical keyboards. Like, I don't know, many of you might be actually already a mechanical keyboard aficionados. There's this trend, and I mean, we will talk more with our guest, but this is something that has developed over the past couple of years, people building their own keyboards and hacking not only the hardware, but the software as well, to get to the point where they can really tweak everything. And whether it's a wired or Bluetooth keyboard, there's tons of stuff and tons of room for tinkering there. So we're going to hear today about a custom firmware for mechanical keyboards that happens to be based on Zephyr. It uses a lot of Zephyr goodness and adds on top of it. So really looking forward to learn more. Even if you're not into keyboards yourself, even if you're more in the pure embedded side of things, you're more an IoT device maker, please stay tuned, because it's still you're still going to learn a lot. Like there's it's kind of like those really nice examples out there of how to use Zephyr for real world applications. It turns out it's open source as well. So with that was for a long intro, but I want to make sure that people had a chance to join. Let's bring our guest on the screen. Hello, Pete. How's it going?
I'm awake. That's good. I'm here.
Yeah, 6 a.m. for you, right?
Yeah, and as I was saying before we started streaming, I'm going to do my best to not get too excited and wake the kids up here this morning. Doing well.
Yeah, well, so you're joining us from where?
Yeah, so we're in Portland, Oregon. Rainy, not so sunny Portland. I was seeing some comments about
Oregon
sun already here, and not much here right now.
Okay, cool. Really, really excited about today's topic. Let's see about this addiction, whether you manage to get. I will be super looking forward to recommendations with regards to a cool equipment. But yeah, tell me about yourself maybe before
Sure.
we get started, right?
Yeah, so I come from a software engineering background. Been a software engineer, I guess, almost 20 years now. Most of my time actually spent doing healthcare sort of back-end work on healthcare software for quite a few years. Sort of fell into embedded development accidentally here through keyboards, actually. I never thought I would. I sort of just always bought an off-the-shelf keyboard and used it. Eventually, like it sounds like you're at the precipice of got up my first mechanical keyboard and fell in love with it. And then, of course, as an engineer and a tinkerer, immediately started getting too deep. And that included sort of the classic open source problem of finding an itch to scratch, which inevitably led me down this current rabbit hole, which is here we are. I'm the maintainer of a keyboard firmware, which was not on my plan, right?
The itch to scratch, that's actually one of the things that, like, whenever someone asks on the Zephyr Discord, there's really often people, like, as in really, really often people being like, hey, how do I get started with Zephyr? What are some good resources to learn? Sure, there's some pointers to great tutorials, etc., out there, but nothing something is better than just, hey, I have like this actual thing that I want to build. And this is when you really have an excuse to learn by solving real problems, even if it's for fun with a keyboard, right?
Yeah, right. Like you can certainly synthesize or fabricate some sort of like, oh, I'll do this thing. But when you've got something that truly is like, I want this to work for me, it certainly totally helps with in terms of like motivation and giving you that focus, you know. So
Yeah.
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 So hey there.
So where should we start? Like what's ZMK then? I guess like how what does it mean to I mean, building a keyboard on the mechanical side of things? I guess I kind of get it. Like you want to get the layout that really suits you and get the keys to do exactly the right kind of like noises and like have all the perfect layout for all the ergonomy as well. But yeah, on the software side of things, what are sort of the things that are needed? I guess.
Yeah, right. And so, at its essence, keyboards can be pretty darn simple, right? Like there's the circuitry is them not particularly complicated. Keyboard matrices give you a little bit of like, oh, fun, there's a matrix, whatever, but not that inherently difficult. But to your point, when it really gets interesting is when you want to do more than just like one button does one thing. And I can hit this and there's an A, I can hit this, there's a backspace. But when you want to do much more than that, where you want to do things like, oh, I can have combinations. If I hit these three physical switches at the same time, they're going to do some other behavior. Or I want to have sticky keys. Like sticky keys is a thing that your operating system might do, but it turns out that's also a really useful thing to have your keyboard to know how to do, because it actually knows what other inputs it's receiving. So you can do more complex behaviors there. And so there's also this concept of layers that is really useful. So if you've ever used a keyboard where you have like an FN key and you hit the FN key and suddenly your F row does something totally different, that feature is basically a dumbed down version of this concept of layers that many of these custom firmwares have, where you can layer on other stuff on top of your base set of functionality. So like, let's say I want to have a number pad that shows up under my right hand. Just if I hold a certain key, I can do that. Or I want to have arrow keys under my fingertips the second I hold a different key. Or I want to have a gaming layer where I can just totally just switch to that gaming layer, and it puts certain number keys right next to my fingers so I can easily switch to my different weapon. I don't game, so again, this is foreign to me. But, and so that need for like really make it do what you want to do immediately makes it more complex, because you could write a really, really simple firmware for a keyboard and probably be like 100 lines. Like it truly would be pretty small. It's literally like detect an input, have a simple mapping of like one spot to a single letter and do it. But the
Yeah,
fun
like using Arduino pretty much. I'm sure there's Arduino-based firmwares out there, right?
Right. And so the other thing certainly is like, as soon as you get into Bluetooth, there's a whole host of stuff around like key management and multiple profiles. One of the cool features that we have is we support any number of like fast profile switching. So when you're using your keyboard with like your work computer and your personal computer or your computer and your phone, will like quick key press and suddenly you're typing and sending all those key presses to your phone, or quick key press and your personal computer, now you're chatting with your wife or whatever, and then quick key press and now you're Bluetooth is sending key presses to your work computer and you're back to it, right? So things like that. As soon as you start getting to that, there's all sorts of more things that are going on, right? That add to the complexity behind like a simple USB. I plug it in and that's an A, right?
Yeah, right. Okay.
So, yeah, and so that's where you start needing to have a bit more complexity to what you're doing, and then also on top of that, there's management of all the other subsets and features, right? So like I want to have a little OLED display that's showing, my active profile for which keyboard, which host is receiving my input, and I want to put the words per minute automatically calculated, and there's a little graph that's showing like my WPM as I'm typing, anything like that. There again, you're adding complexity. You've got to figure out how you're going to surface all the data to this other area, the display subsystem, etc. Yeah.
Yeah.
So
Okay. And so from day one, you went with Zephyr for your experiments, basically?
Yeah, fairly quickly. And so just the tiny bit more history. So what really got me going on this was at the time I was working from home. I bought myself a split mechanical keyboard. And so as you explore this, depending on the hobby, you'll find there's this split keyboard concept where like you can position two halves of a keyboard wherever you want for ergonomic reasons, right? And so I bought myself this really nice split mechanical keyboard. And working from cafes once or twice a week, I was like, oh, I'll bring my new keyboard. I'm excited for this. I'll go to the cafe. And I bring this, and suddenly I'm like, I'm moving cables to like connect the two halves, and the USB cable also is there. And where am I going to put my coffee when I've got all these? And so, like, immediately I was like, I love this keyboard, and these cables are annoying the heck out of me.
Mm.
And that was the itch. That was actually the itch. It's like, I love this thing, but like all the cables are annoying me. I want to just be able to travel with this thing. And so, um, that really was the thing. It's like, this needs to be Bluetooth. Like, I got to ditch the wires, right? And so, surveying the landscape of like, what are my options here, especially as a newcomer to embedded, I had a checklist, right? Like, I knew I needed the normal stuff, but I also like, I need a solid Bluetooth stack. And surveying the scene, this was almost 4 years ago now. There are quite a few options, but not all of them check all the boxes in terms of like, you know, being able to easily program targeting multiple hardware targets
Mm.
and open source friendly, like if and powerful, right? And well equipped with lots of support for other stuff, right? Like, and so when you survey the screen in terms of like of options for real-time operating system, Zephyr has it as I want to say the market corner, but certainly that's a strength right there in terms of Zephyr is the solid Bluetooth stack that's open source, um, and lets you target multiple hardware platforms, right? And so when I was first, researching my options and looking at this, a lot of folks in the existing keyboard world were excited about like the STM WB series from
Hmm.
ST that is Bluetooth. But then a whole other sort of niche folks over here, like, Nordic. And so like I started looking, it's like, I can't just pick one of these companies, SDK they provide, because I got two different people telling me like this is the best hardware. You should like, okay,
And I'm
so
sure there's
what
even people doing ESP32,
right.
probably,
Yeah,
right?
for sure. Now I pretty quickly ruled out ESP32 just from a power use perspective. Like
Hmm.
a lot of the sort of the maker world use it, and I think it's great for tons of uses. But for an always on device like a
Right.
keyboard, where it's like always detecting key presses and it can't just like go into deep sleep and wake up every minute to like read some sensor, it sort of like that got ruled out a little bit, which kind of worked because at the time the ESP support in Zephyr basically wasn't there. So that
Mm.
didn't exclude me, although I've been excited that the support's grown a lot in the past few years since I started using it. But for sure, the like solid Bluetooth, and in particular, I come from an open source background. Like I did open source in college, and I was really into it. And one of the big things that I love is that like, especially like on Nordic chips, like there's no binary blob. Like you can skip the soft device stuff, run the open source controller portion, and you truly have like a all the way down open source solution, which as a sort of an open source person, I really value and appreciate. So that also was a big selling point for me is like, there's an option there that doesn't involve any sort of binary blobs. And that's not true for all of the hardware. And I get there's lots of reasons that that's a thing, fine, but it appealed to me too. So that really was the big thing for me is like solid general operating system, real-time operating system, tons of subsystems for whatever I need to use it for, and a rock solid Bluetooth stack. And it was sort of a no-brainer once I really started digging.
Hmm. Yeah, no, that
So
makes sense. Well, I mean, maybe that's actually a segue into since we started to talk about the actual hardware. I don't know. Like, do you want to show us how to like typically install ZMK, or like how should we get started?
yeah, so first, obviously, the first thing is get some hardware you can run ZMK on. Lots of options there, especially if we have folks on the stream here that are experienced hardware hackers. The simplest for me, like literally most of my development work is on this, which doesn't look much like a keyboard, but like this is my day-to-day development work, which is
So that's
literally
Nordic.
it's a Nordic DK, and I designed a custom hat for it, a shield for it that literally has like all the common hardware that most keyboards have. So I've got a nice bit of switches, an encoder knob, like a quadristor encoder, a little OLED screen. Although I also support a sharp memory display. There's some really, really nice super low power sharp memory displays that are available that are basically like OLEDs. They aren't backlit, but they're super low power. And so that's my hardware. So if you want to tinker, and just play with ZMK, there's this little project called ZMK Uno. It's an open source hardware. I'll send a link on the chat later, maybe, that literally like you can get it built at GLC for free, toss it on your existing DK, and there you go. You can install ZMK. There's a shield definition for it in our ZMK repo. You can literally sort of west build, west flash, and you can run ZMK on, basically you can turn it into a macro pad. If you just want to like get experience and play with ZMK, that's the easiest way for any of the sort of hardware embedded engineers on the stream here. But if you're looking for like, yeah, there we go. Thank you. Perfect. And so that's my day-to-day like development platform. It's super great because the DK has all the debugging tools and easy, and it's integrated, and I don't have to screw up my keyboard I'm typing on to work on features. But beyond that, it's find a keyboard that has supported hardware. A lot of that is sort of custom keyboards. It's not, you can do it. There are some off-the-shelf keyboards that under the hood have Nordic chips, and you can rank, do bad things to them if you wanted to. But most of the time, it means sort of finding a supported custom keyboard that you can run this thing on. And there's lots of options there. The custom keyboard space, there's sort of two worlds. There's the like full DIY where people will sort of print their own PCBs at JLC, and they'll build them and assemble them themselves and fully on like build it. And then there's the like custom keyboards, but I buy a pre-built device that happens to still be custom in the sense that I can
just like building your PC sort of stuff, like you assemble get the casing
right. So lots of options there, and so you can go everywhere from like I have this is a pre-built split sort of ergonomic QL called the Glove 80 that runs ZMK, and this is on that sort of like I just buy a keyboard and it works realm, right? It's got a nice injection molded case, and it's fully FCC certified, amazing, right? A consumer device that happens to run ZMK, or you can go really DIY, and there's super tiny, and this is using the little Zhao microcontrollers. Happens to be a keyboard design of mine, super small key count, and we can talk about how crazy people get with keyboards if you want. Not that interesting maybe to this crowd, but and this is solder yourself, build it, and then install ZMK on it. And so the installation itself, there's a few different ways, and that's actually been one of the, and we can start talking that. It sort of segues nicely. Let's get into the tech a little bit. There's sort of two main ways to do that, and so one of the things that was super important from the onset, working with ZMK, was making it really accessible, even if we're getting sort of crazy. And so if you look at our docs and sort of installing ZMK, one of the things that you won't often see is like, I'm going to spend an hour setting up tool chain and getting that Zephyr SDK going. So one of our primary workflows is like, you run a little setup script and GitHub Actions will build a firmware for you. And so we've done a lot of work to automate that piece so that we're more accessible for folks that are like building custom keyboards, but like.
Oh wait, you mean you fork the ZMK repo in your own?
So get this, not even that.
Okay.
Because forking the repo means you now have to maintain a fork, right?
Okay.
And so what we've built out is basically a config repo. Has enough automation that using West, we can talk about how great West has been because it's just a fabulous tool here. You can build a keyboard and not have forked ZMK, maintain a fork of ZMK, whatever. It'll just build against whatever version of ZMK you've specified in your West YAML file. And so when I want to build the firmware for my keyboard, I can go in here, edit even in the GitHub, editor if you want to in the web interface, change my key map here. And when I commit the changes, it's going to run some GitHub CI magic, and it's going to build me a new firmware. And then it'll, have an attachment of a firmware I can download and just flash to my keyboard. And nice. So, that was a really fun piece to work on all that automation here, which is like, how do we make that fast? And we've done a lot of work on like really streamlining the Docker images so they're small, and tuning them so that we're as efficient as possible in making that process there, and also just setting up the build infrastructure so it's really easy to to not like fork some random project and download Zephyr SDK and spend a lot of time. I'm seeing a comment here asking about sort of like
Yeah. So,
the
well, so this one maybe just disruptive, but briefly, Fabio was asking, what's your take on hand-wired keyboard? Seems like a good exercise in patience.
Yeah, so if we want to talk about sort of like the DI world, I skipped it because I've not gone through that pain myself, but I always am really appreciative of folks that do. And yes, it's certainly really and if you do some Googling, there's some beautiful designs where folks will like spend an inordinate amount of time, I'm sure, like hand wiring keyboards. They'll use like nicely color coded wires that give this
Wow.
like beautiful appearance. There's a couple designs that use like copper pipe style wiring that are just gorgeous, and they'll do like acrylic cases where you can see them through the bottom, and it's gorgeous. And so exercise and patience for sure, tons more extra soldering for you. And it turns out the config repo concept is really easy because I think we are quite possibly the biggest user of the shield functionality in Zephyr, because honestly, there's most things in ZMK are a shield. And so you can actually push a custom shield to your config repo for whatever handwire you've got, like, set up the pin mapping for whatever matrix you've done in your handwire. And you don't need to fork ZMK. You don't need to try and open a pull request to ZMK to like get your shield definition added. You can have a custom one in your repo and then build it through GitHub Actions and nicely have this like, boom, it's going to give me a file to download and flash to my dice process for whatever custom handwire thing you've done. And so that out of tree support for whatever weird hardware you happen to have assembled makes that easy, at least on the firmware side of things, to get. I'm always impressed with people who do hand wires. I don't have the patience for it. I'd much rather spend hours and hours in KiCad, I guess, instead,
Right.
and get some PCBs made.
Right. On the topic of keyboard layouts, I'm not sure I've seen that before, but maybe you have. Have you seen anyone building a keyboard where basically there's a 4x4 numpad specifically for hexadecimal?
Yeah, so you'd have A through F. I could totally see it. That would be a great build. Do it. Please do it and send me pictures. That would be pretty fun to have a hex numpad. And honestly, so there's something you could also easily do. I typically have a number pad under a layer on my hand, so I'll sort of hold one thumb, and now I've got a number pad on this side. It'd be a fun addition to put those A through F right, and a nice grid for that when you do that. Yeah, that would be fun.
Yeah.
I like it.
And Fabio is actually sending a shout out to you guys are on Discord, right? Like and apparently, and I haven't checked it out myself, but apparently the show and tell is where I should not go.
Danger lurks there. Yes, for sure. If you're trying to protect your wallet there, Benjamin. Yeah, we've got a pretty active show and tell channel where people are showing their handwire builds and custom 3D printed cases and all sorts of fun things for sure.
Yeah, so a shout out from Tobias regarding the GitHub Actions. And I don't know if you want to take this question now or, but like, how easy or is it hard to keep up with new Zephyr releases? Is this a Zephyr or a ZMK problem? Yeah, maybe we can talk about like what are some of the main features in Zephyr that you're leveraging. And I know that, and we were briefly discussing before going live, there's certainly a lot that's happening in Zephyr upstream that might sometimes overlap with the kind of functionality that you've been historically developing in ZMK, like the input subsystem and things like that. So, yeah, thoughts on that? How you keep up, basically?
Yeah, I mean, I'm sure if you dig, you can find the open PR I have right now for our Zephyr 3.5 upgrade. And so each upgrade we've done a few. I think we started on 2.7 maybe when I got started. I have to go
that would make sense.
And so each upgrade has been different in terms of scope. And so whenever there's a new Zephyr release, I'm always a perfect mix of super excited and super scared.
And that's one every 4 months, right? So it's
and certainly we don't track every release. I think I'd pull my hair out. I wouldn't get any other work done if all I did was do Zephyr upgrades. And so I tend to do sort of every other or every third release. I do the work because I really want to get all the awesome new stuff that's coming out in every release. But depending on the scope, it can be easy or not, right? And so um, there's a few things that sometimes make that challenging. One, and we'll hopefully have time to touch on it, the way we use device tree, um, and how extensive we have in terms of number of custom boards and shields means that any sort of changes to any of the device tree stuff, compatibility
Mm.
changes, or like new nodes, like we actually leverage device tree for our key maps, which is both a blessing and a curse, because like we had this node, a shortcut just called reset, that was used. You could put it in your key map whenever you want to reset your keyboard. This is fabulous. But when a Zephyr release adds the reset drivers, and now most hardware now has this node with a shortcut of
Oh,
reset,
wow. Yeah.
suddenly lots of people's key maps are breaking because they're trying to reference a reset node, and we're trying to create a
That's
new
so busy.
node with a reset. And it's like, hey, we already have one of those, right? So it's stupid little things like that where suddenly like our key map, because we took a little bit of a shortcut to use device tree, which is actually super powerful and I love it. It also means that we're a little fragile there, because device tree often changes and shifts with Zephyr releases. So there's one that's like sometimes challenging. It's stupid stuff like that because we're abusing device tree that way. And then the other thing is, often the core stuff is fairly stable, but there's little things, right? So like, so on the USB side of things, the way that CDC nodes got created for like logging to a virtual serial device changed in one release, right? So
Hmm.
instead of like it just being like some K-config setup and that's it, and like behind the scenes some device would get created, the setup got moved to device tree, which totally makes sense, and it's nested under the USB device node. There's this new Zephyr CDC ACM device that you put in the device tree. Awesome. But now it means that like every board needs to get upgraded to move to that new way of doing things, right? So like little things like that end up sort of catching us up because we have these config repos that are so easy to build out of tree boards and out of tree shields. The second I change something like that, like I need to have a blog post and I need to like warn people about upcoming changes and document how it is that you like, if you want to have USB logging still
Migration.
work, you got to do
Hmm.
this, right? So those sorts of things, like little things, are the kinds of things that like snowball a little bit in terms of scope, because now I've got to do, like a bunch of upgrade work to a bunch of, device tree files. I need to document it in a blog post and have lots of people test. Testing, of course, is a big thing. The Bluetooth stack always gets tons of work done on it, which is awesome. But it also sometimes means there are regressions, and we have keyboards in the wild that like talk to all different sort of host operating systems, Mac OS, Windows,
Mm.
stupid Intel drivers on Windows that don't like 2M, PHY setup. Like, so the testing there is pretty extensive. So I don't think that's going away, but certainly it's a part of what we're doing to try and have people's keyboards still work. But it's also great because we get new stuff. We get the input subsystem, which we can maybe go there a little bit. Like, we use various parts of Zephyr. I can talk about them a little bit more as we go. But one of the new things I'm excited for is the input subsystem, which was in the new Zephyr release.
Mm.
And we right now leverage Kscan, the Kscan driver, for the most part, for our actual like key press detection. We have custom Kscan drivers in our tree that do a lot of the heavy lifting for us there. But I've slowly been working on the input, like the pointer device support. A lot of people in the custom keyboard space like add track points or track balls or mouse sensors to what they're doing, and so I'm so happy because we're leveraging the input subsystem for that, and so I'm doing the Zephyr 3.5 upgrade. One, because the Bluetooth stack has some really important fixes that are going to help a bunch of our users, and we really need it. But two, it's going to let me use. I have another draft PR that's adding pointer support, so I have a like a little trackpad module. This is another Uno shield. I tend to do that with everything I do, so I can easily like throw these on DKs. But there's tons of people that are like super excited for pointer devices support. And the input subsystem, I was a little wary when I saw it in development because it was a little unclear like how that would mesh with all the Kscan stuff that we already built on top of.
Mm.
I've actually been a little sort of pleasantly surprised with the way it was designed, that is going to not totally replicate the way Kscan works, but just actually honestly kind of good. Some of the design of the Kscan API is a little challenging to work with. Not horrible, just stupid little things. But for like pointer devices with like XY, like deltas and all that, it's really well designed. I'm so excited that like I didn't have to do anything, and suddenly there's this whole new subsystem I can easily plug into it. And there had been some preliminary pointer work done for ZMK a while ago that just I wasn't ready to look at what the contributors had done. And when I got to refactoring it against the input subsystem, it was like, I'm going to toss a bunch of code we don't need anymore. This is great. And so new Zephyr releases is definitely one of those, like, scared by it but love it, because I always get whatever new stuff. The power domain stuff is something that I have a PR up for. There's a few more details to work out on some of the pieces, but like the power domain stuff that got added more recently is fabulous, and it's going to perfectly solve some of the challenges that we have with some of our peripheral hardware. Those screens I was talking about, RGB keyboard people love their bling, and so like RGB underglow and LEDs are power hungry little suckers. And so the power domain stuff that was in a couple releases ago, I was so excited because we can finally fix some of the peripheral power management stuff that we've got, in particular, like cutting power to them and restoring power and having that all sort of magically work. Is super excited. And there again,
So
like a new Zephyr release, I get new goodies I get to play with for new features.
yeah. So would you say most people that use ZMK use it in a wireless battery powered context?
I'd say that's a lot of our user base. When I started it, the tagline that I came with was like a wireless first keyboard firmware, which is not to say you have to use it wireless, but like that's one of our focuses, right? Like being mindful of power use is super important. Because a lot of time these devices don't have room for big, chunky, giant batteries, and so everything that we can do to be low power matters, right? And so I would say, I would guess 95% of our users are folks that are using wireless keyboards. But I actually love running wired keyboards with ZMK because it gives me an excuse to make sure that like other hardware targets work well. And so
Mm.
there's a staunch group of folks that still use EMK because they're used to the power around like the key maps and the functionality it offers, and so they're happy to run it wired too. And so things like the RP2040 support has been
Mm.
super important for that being an easy option for folks that want to run ZMK. When that chip came out, I was like, yes, this is going to blow up, and yes, we got to get support for it. And that sort of inevitably happened. No
Do you
surprise.
guys actually use like the PIO stuff for like the
Not
most
yet.
performance or?
Almost. And so actually that's one of the other things I'm excited about. The newer Zephyr releases have the PIO sort of driver infrastructure there. And so using that, for instance, for WS28112 LEDs is
Yes.
going to be awesome, right? That's a big one I'm looking forward to, because for the most part, it's been like you have to use an SPI pin, and if it's on the wrong pin, you're out of luck. There's not a lot of like, I haven't spent the time to do like bit banging drivers. And so like the PIO stuff for that is going to be super cool. I've seen some other uses, like using it for USB host support, which is a really interesting idea too, for being able to like chain other USB devices. I'm excited for, the PIO stuff is very cool. We don't leverage it yet. Inches away. Looking forward to it. Yeah, for sure.
Nice.
So yeah.
So yeah,
So
you
initially,
mentioned device tree. Maybe I don't know. Like, do you want to show us a bit about like what's under
yeah.
the hood?
Sure. Yeah. So early on, many keyboard firmwares. I think I have a different here. There's an example of one of our key map files to give you a sense of it. Early on, a lot of keyboard firmwares will have sort of like you write your key map in raw C, and they have a bunch of like sort of macros to make this easier and whatever. But it's still like I'm writing C code, and early on, what I really wanted to do was to have more of a declarative key map that was not code, but sort of assemblage of metadata and you know not code, but description of a key map, which is actually super important, because when you eventually want to do runtime key map updates, you're not going to do runtime writing new C code and then
Yeah.
sending it to my controller over some USB thing. That doesn't make sense, right? So having it be metadata and assemblage of stuff makes it easier to have that down the line. And so when I was looking for like what format do we want to store this in, it's like, hey, we have a format. Device tree exists. And so I for all of your viewers, this is not how device tree is supposed to be used. And turns out you can do really cool stuff with it. I always feel a little awkward whenever I'm sort of sharing this outside of the keyboard world, because literally all of the device tree documentation talks are like, this describes hardware, this describes hardware. And I was looking at it, I was like, but does it have to? And so we certainly sort of do things a little bit backward with the device tree, but fundamentally, we have a key map node and it has a compatible value. Like if you've done any sort of device tree work, this looks familiar. But what I'm describing isn't like compatible on some particular piece of hardware. It's a compatible node that's like, this thing's a key map. And so I mentioned layers before, right? Like an FN key gets you a new layer. And so the very next thing is like each sub node is now a layer in your key map, right? And then, and this is where I'm actually really happy with how we sort of design things. Each key map layer just has a set of bindings where each binding is like a key position, this abstract concept of a key position. It's a physical location on the keyboard, right? And so this basically says that on my default layer, on that first key position, which is probably in the top left corner of your device, I'm going to do a key press. I'm going to bind a different device tree node that's the key press node. I'm going to pass it a binding parameter, which is a Q, which turns out under the hood, the Q is actually just a C macro that is like some HID usage. I don't know. Read the HID spec. It's a great spec if you're looking for some bedtime reading. But there's some included header file that actually makes this Q be the actual HID usage that gets sent across the wire. And this is really handy because you can, instead of binding just like the key press behavior, you can instead bind a different device tree node in a certain position. And device tree has this concept of like a p handle array, where you can put in that array any list of devices and then binding parameters or cells, as they call them in the device tree syntax. And so I can momentarily switch to a certain layer when a key is held. And so I can, instead of using my key press device tree node, and I'll switch and show you where these defined in a second, I can instead bind this up. And under the hood, this is just a new driver API. So just like you have a driver API for Kscan and for, the LED strips or whatever other driver API ADCs, we actually have a custom driver API that's just behaviors that you can have work in your system. And so it turns out we have this custom, and as long as you bind some behavior, which can be, the driver API is fabulous in Zephyr. It's this nice abstraction layer. Like, I don't know what hardware is under the hood. If I'm talking about ADC, reading an ADC value, same thing. I don't know what under the hood happens, but I have this driver API that lets me like send a pressed state and send a released state. And maybe that's going to, send some HID code to the host. Maybe it's going to change my layers. Maybe it's going to do a sticky key behavior. I don't care. And so this is where a lot of the power comes from, is like we can use device tree to describe the assemblage of all these behaviors and actually link behaviors together for like combos, whatever. And then under the hood, it's going to when we do the whole compilation process, it's going to, or parse the device tree, spit it out into, and behind the hood, it's all C code under the hood, but fundamentally it lets us have a really powerful, really flexible syntax here. And so when I that MO I was showing, let's see, I gotta switch to typing here instead of chatting. So like layer taps are a thing. It's a key there. If you tap the key, it'll just do a key press behavior. But if you hold the key, it will momentarily change a layer. So like a dual use key, depending on what I do, if I tap this key, it's going to send an enter. But if I hold this key, it's going to get me to another layer for my number pad on my keyboard, right? It turns out that's just a like taking our hold tap behavior in this driver API and using two different behavior drivers linked to it, our momentary behavior and our key press behavior. So we basically built up this system where you have this concept of like the behavior driver API. And because device tree lets you link, I'm going to, link to this other node easily, I can define behaviors that actually assemble other behaviors and make them do the heavy lifting, right? And so it's a horrible use of device tree. We're not describing any hardware, but it's a perfect, although very verbose, syntax already supported by Zephyr that lets you assemble a bunch of driver instances and make them all work together.
Yeah,
And
well, I
treating
guess
it pretty well.
question to you and maybe to some of the viewers that are like maintainers from the Zephyr community, etc. Like you keep bringing up that it's a terrible use. It's certainly out of the recommended use that it should be describing hardware. But like, what would be the alternative then? Because I mean, if it does the
Yeah,
job,
right.
right?
Right, exactly. Like the alternative was like some God, more YAML,
Like
I guess.
JSON,
Right.
whatever.
Yeah, right. Yeah. And so ultimately it was a I'm all about pragmatic choices. Like, yes, you should make smart choices, but also sometimes pragmatism wins, right? And so it was there, it was available, it perfectly translated to what we needed, which was code behind the scenes that linked
Yeah,
to these
yeah, it
entities, right?
compiles, right? Like you can actually do lots of checks and
Yeah. Right. So it works. It works great. And so, getting back to the, the key maps here, it's a bunch of layers. Each entry in this bindings array is whatever you want it to do when that key gets pressed, and it could be a simple key press of a character, it could be some a tap dance. So like tap dances are super cool. Like if I hit this key once, it's a space. If I tap it quickly, it actually does caps word, where it will like capitalize all of your upcoming letters until you hit a space bar. So you want to type some constant in C, double tap your shift key, type the whole constant name. The second you hit space, your caps is gone and you're back to, normal typing, right? And so tap dances or, combos, multi-key combos. I hit these two keys together at the same time and it's going to spit out the, the left GUI, the Windows key for you. So those are all the sorts of things that we specify in our device tree and gets translated into C code. Yeah. Oh, I love this question. Dynamic key map configuration plan. Did someone pay you to ask that question? I think they must have.
I don't know, but
I
it's
did.
like
I didn't.
right on point, right?
Yes, there is dynamic key map configuration plan. From very early on, I knew I was eventually going to want to do it. And that's part of the reason I did this sort of convention sort of metadata approach so that we could do it. I'm literally starting on that hopefully in another week or two. I've managed to pool together a bunch of keyboard vendors that are going to sponsor me to work on the runtime key map functionality and get started on it. And there's all sorts of fun tech involved in that, like setting subsystem, which we already use pretty extensively for other stuff, is going to be used under the hood for storing sort of dynamically changed stuff. And then we've got to do the whole sort of what protocol are we going to use for communicating that. What we're probably going to use raw HID for that, which is sort of like HID, but again, sort of off use for what HID was originally designed for. And the nice thing here, we're going to use the HID layer and let us do HID over either Bluetooth or USB so that the key map configuration will sort of seamlessly work for changing it over Bluetooth or changing it for a USB keyboard and communicate over the HID layer to send, do API requests basically from the host to the keyboard and change the stuff. And so fundamentally, it'll still work the same way, but instead of sort of the device tree syntax, it'll be this generic, metadata concept like, oh, I've got a key position and right now it's got this key press behavior bound and the parameter passed as a queue. I'm going to change that, like bind the, the layer tap key here instead and then do that. And so, yes, it's planned. I'm hopefully starting on it in another week or two. I've got enough sponsors that are going to sponsor me to work on it, which is going to be awesome. And get going on the firmware side and then the UI side. Yes. Yeah. In the works
Awesome.
and on the precipice. Yeah.
And so, a quick question maybe regarding the project itself from an open source perspective. You're the main and only maintainer of the core of the firmware, or are there other people?
Yeah. Yeah. So certainly started it as me here. We at this point have one other core contributor who has sort of commit rights and PR review and consumer stuff. And then we have a docs lead who's in charge. I am so grateful. So grateful for Sam's work on the doc side of things. And so, I'm the project lead. I do most of the core. That's not true. That's actually kind of a lie. On a lot of the low level core, there's mostly me doing it, but we've had a few folks contribute there. The behavior side of things, like this like layer taps and stuff, a lot of the like really complex behaviors, we actually had a couple contributors early on. They're like, this is cool what you're doing, and did that and added tests. I'd love to talk about the tests when we have a second here. Added tests for it. And so since then, we have a lot of contributors that are contributing adding on, like not many people have touched the low level, like all the Bluetooth bits. It's mostly been stuff I've worked on, but a lot of folks have been contributing, sort of adding pieces that haven't been a priority for me. And certainly one of my challenges has been balancing sort of reviewing PRs for
Hmm.
stuff that isn't stuff I use, but it's still awesome that folks are doing it and trying to use ZMK for it. And so I'm sort of the main reviewer. Joel just recently came on as a core contributor so that he can take on some of the stuff that isn't as much of a priority for me, which I'm super excited for. And scaling has definitely been a challenge. The overlap of sort of keyboard users and solid and embedded engineers, the Venn diagram there is smaller, right? And so, but what we've really tried to do, at least for like the behaviors, is make it really easy to not have to be an embedded engineer and still write them. Like if you can write C code, but maybe you aren't as familiar with like shared IRQs and semaphores or any of those more complex low level things, but you know how to write some basic C code and know what I wanted to do when I press or release something. That's a little bit more accessible, and we have nice unit tests so that you can write that and not have a DK sitting here so you can debug some stupid problem with ADC reads taking too long and whatever, right? And so but yeah, so it's a fairly small core group, but we've had a pleasant amount of people join in and contribute stuff, which has been good. Yeah.
Nice, awesome. So did you say you want to talk about tests? And I would
Yeah.
encourage people in the chat. So we've been seeing really good questions so far. We have only like 14 or 15 minutes to go. So if you have any questions on your mind, don't wait, because for us to take them live, they need to come now.
Yeah, for sure. I love the questions. And so I mentioned sort of CI, continuous integration using GitHub Actions to build firmware for people. Early on, I'm a big proponent of testing. And when I first started getting this, like, what the heck does testing look like with embedded development? And honestly, at first, I was like, and I just didn't have any testing, and that was that. And certainly that was sort of early phase of the project. I was trying to make stuff work, right? But as I started getting into like the key map functionality and the complex behaviors there, I mean, it's like, some of this stuff is really complex. If we don't have tests for this, it's going to be a maintenance nightmare. So what does that look like? And I looked at like the Z test stuff that exists, and it looked okay to me. But I explored things a little bit differently. I was like, I really need something that's a little bit more sort of like integration testing style. Because for me, when I'm writing code, like if I have a nice like test around the edges, I don't necessarily need like a test for every single function in my code. If I'm picking, I want to just like the described behavior should work the way it's supposed to work and keep working, right? And so if I'm going to pick my poison, I'm going to try and do more of that sort of general behavior testing. And so at the time, I happened to have been drawn into doing more front end testing related stuff, and React has this really cool concept of snapshot testing that was sort of popularized with the React stuff. um, and so we ended up like, what do I really want? I want to be able to like synthesize some inputs into my system, and then I want to observe sort of externally the outputs, black box more style testing. And so um, at the time, that's when I got really excited, and I discovered all the POSIX target stuff. And so you can build ZMK, but you don't have to build it for a particular hardware target. You can actually build it as a little POSIX process and run the POSIX process and run our embedded code just like literally as an executable. And when I found this, I was like, this is perfect. I can run tests. And so if you go and look at our testing, I'll show you maybe a not too complex test. Key press, our key press test, for instance. So key press is pretty simple, right? You trigger an input to press a key, and it should send something to the host. And you release the key, and it should release the key from the host. And so turns out that you can mock inputs to the system in device tree too. And so what we did is we added a new mock Kscan driver. So the Kscan, under the hood, the Kscan driver API is what's used to, like, there's a press at an XY event, or there's a release at an XY event. So why don't we just have a sequence of synthesized events with certain delays between them? And that will drive your inputs to the system. And it's literally like we can synthesize someone pushing and releasing a key in your keyboard. Cool. Okay, so we can synthesize the inputs to the system. How do we verify the outputs? Well, it turns out You can do logging really easily in Zephyr. Cool. And when you run as a POSIX process, all that log output can nicely get spit out to the standard out, and you can capture it. And so when we run, let me actually run this test. Where are you? Here we go. You can basically build a POSIX process, run the POSIX process. Our synthesized events are going to generate output. And then we can basically do some fancy pattern matching to basically filter out all the junk we don't care about in terms of logging, to just identify the output of that log that's the relevant sort of black box stuff we want to observe, and compare against a snapshot. And this is what sort of the classic React snapshot testing does. Like we output some DOM and we compare the DOM, like, oh, it spit out the same DOM to the browser. In our case, we just like want to verify that what happened is like we sent the right HID usage to the host, and then we released the right HID usage to the host. And now, whenever anybody wants to refactor the key press behavior, if you could run this test, you know you haven't broken that this concept of like triggering it and then triggering the release is really going to send HID stuff to the host. Not that interesting for key presses, but when you do things like combos, pressing two physical keys at the same time, and the timing when there's overlapping combos, like one particular physical key is involved in like three different possible combos, right? Like that key with this other key does this thing, but that key with this other key over here is supposed to do some other combo. Like the timing of that, the interactions with other behaviors in the system, making sure all that works, we can synthesize exactly the timing of those sorts of inputs via the synthesized sequence of events, and then make sure that the expected behavior occurs. And it's great. It's done so much for like catching regressions, Zephyr upgrades when we have to do like major refactors. Just recently I did a major refactor where we had used the heap functionality, and actually we're like allocating and freeing memory for some of our eventing system that's used sort of under the hood for doing stuff. And I realized I really didn't want to do that. Like I designed it pretty early on in I'm an embedded developer now days, and it's inelegant at best and painful for more memory constrained devices because we have to allocate this big heap. And so I was doing this big under the hood refactor to like move away from using the heap for all of our eventing system. And is this thing working? Have I broken things? I had an extensive test suite of like all of these complex behaviors using the eventing system to catch my screw ups and make sure it worked. And so basically all of these sort of snapshot based tests that under the hood are just like a compilation of Zephyr for the POSIX target. Catch any of the regressions, or let us refactor with some confidence here, which is pretty fun in terms of being an embedded target, but not needing to run on device. And I know the Twister stuff is pretty cool, but like as an open source project, we don't have a farm of embedded devices that we can easily send stuff to. Like it's some DKs on a desk, right? And so I'm being able to synthesize this for POSIX targets has been really cool. Yeah. How do you test hardware-related components such as BLA, USB, custom integrations, etc.? Yeah, thank you. So that's something we've been exploring more recently. A lot of it is physical manual testing, right? So like when we do a Zephyr upgrade, I'm flashing two devices, and this is we can talk about Bluetooth and the joy and pain that is Bluetooth. But so a lot of that's on-device testing. But more recently, we added some BabelSim tests. BabelSim integration got added to Zephyr fairly recently. It's really cool. And so like more recently we added some Bluetooth tests that use the same pattern, right? We're synthesizing inputs to our system, but we're spinning it up with BabelSim. And so there's a virtual, Bluetooth, connection, hardware, physical devices that are communicating with each other. So we actually spawn ZMK as a POSIX process with BabelSim, and we launch some POSIX processes that are Bluetooth centrals, and they connect to our keyboard over Bluetooth. Big giant air quotes here, but like the BabelSim stuff is super cool. And so it actually automates pretending to be a running Bluetooth keyboard and a running Bluetooth host that's going to connect. And then do we actually properly send our input over Bluetooth to this new Bluetooth central? And so the Babelsim stuff is super cool. I'm super excited. We added some basic tests already. I've got some other changes to our Bluetooth stack. I'm going to be, doing some more changes there to do it. And so that's awesome. That's a great example of like pushing the limits on what you can test without actually being on device. Doesn't replace
Yeah.
it. It certainly doesn't, but it's a
Yeah.
cool new addition that I'm excited for.
Yeah, we'll definitely check it out. I think I said in the intro that ZMK is one of those projects out there that are sort of the like really good citizens of what can be done with Zephyr, and that I really encourage people to use as an example. I didn't know you were using BubbleSim, and I was always looking myself for examples of how to practically use it. So I will definitely check that out. One thing that Tobias quote in your CLI example, I guess. How did you modify the test command to run your tests? It looks like it might be a custom command, right?
Yeah. So we do have a custom West command here, and so we plugged into the West command stuff, and this is really sort of a very thin veneer over running a little shell script, but it makes it easy for sort of West to be the entry point, and it's literally like the world's smallest West command here. It parses a path argument, and then it literally just passes it to the shell script we'd already written. And so custom West command made that really easy to sort of tie into that. But fundamentally, like I started writing it as a shell script, and why change what's working. So under the hood it's a little, some shell. And it literally is just finding a bunch of targets to build, do some West builds, and then literally run the resulting executable and look at the output.
Nice. Fabio is asking, will you be at the Zephyr Developer Summit in April in Seattle?
I'm really hoping to. I haven't broached the topic with the family yet, and disappearing for a while to go play in Seattle. I'm really hoping to, but I don't yet for sure if it's in the cards. Yeah.
All right. One thing that I think we were discussing about before going live, and that I said I would ask you, anything in Zephyr that you're missing, or you feel would be different, or that you're looking forward to, that is in the roadmap, and that you think will make your life easier as ZMK developer?
That's a really good question. I mentioned the power domain stuff is super cool. Missing.
It's certainly not device tree, right?
No, we've got plenty we're doing wrong there. I cannot see any ESPs. I'm going to touch an ESP in a second. Stuff that's missing, that's a really good question, and it's tricky because for the most part I've been super happy with it, and not had any problems in terms of missing things.
It looks like even setting up the whole tool chain, you sort of have the nice workaround where even people who are not developers, they just use the GitHub configuration stuff, right?
Yeah, right. And so most of that's pretty darn good. Honestly, there's nothing that's like an itching, burning.
I didn't expect that. I really wanted you to point at something, but fair enough.
I've also tried to be a pretty good citizen in terms of like upstreaming stuff. And so like, UF2, I don't know, most development engineers don't use UF2 much, but UF2 is fabulous. Microsoft came out with this great spec and theory of like, you could just flash with a USB mass storage device. Like it doesn't need to be hard. We can figure it out. And so literally like it shows up like a USB drive, and you drag and drop a file, and it just works, right? And so like I've contributed a bunch of the UF2, like that was missing, right? Like we ended up doing that ourselves, like this post build command stuff. And I was like, but Zephyr has build target concept, like hex or bin or whatever. Like, okay, so I'll upstream it. And so like Zephyr has UF2 support now because we needed it, right? And so if anything, it's like keep doing that, which is I really appreciate that Zephyr, even though it's like a commercial source open source project, there's lots of companies that are involved behind the scenes. It's some random Joe here is still pushing PRs, and they're going in. And so if anything, it's like that. Keep doing that. Keep being an open source project that still lets random people that aren't from ST or Nordic
Oh yeah,
contributing to this stuff,
we get a dozen a week. Like there's a dozen, if not more, people a week that are, like you said, random folks that just have they scratch their own
Yeah.
itches. I think Jovan joined late, so maybe you can briefly sort of remind what's sort of the story for ESP32 and why maybe it's not so popular.
Yeah. So ESP tends to be fabulous for the maker community, but they're comparatively fairly power hungry for a device like a keyboard that needs to stay on all the time. Like I can't go into just full deep sleep and then wake up a minute later in order to
Oops.
do something. I need to be running the whole time, and so we have generally not used it. It's not used much for keyboards, but newer Zephyr has nice ESP support. When we're done with our Zephyr 3.5 upgrade, I've tested it on an ESP32C3 target, and it works great. And so, there's a little bit more involved there. It involves the whole West blob stuff, and so I did some basic testing. I don't that microcontroller is sitting in some random box. I won't go searching for it right now, but C3 worked. I was able to flash it. It loaded Bluetooth. It was advertising. I was able to connect, send key presses. It sort of just worked, and that's sort of like the joy that is the Zephyr stuff, right? Like having that sort of stuff. Like, yeah, another one. And so yes, it works. You have to do some tricky stuff with West Blob in order to download some of the binary blob stuff for the Bluetooth stack portion behind the scenes on ESP.
Yep.
But it does work. If you want to play with it, hop on our Discord. I'm happy to tell you sort of like the extra couple bits that were necessary in order to target it. But yeah, it sort of just worked once the ESP support in Zephyr was there. Yeah.
Nice. Okay. That might actually be the last question that we like. Anything else you wanted to share in the minus 1 minute we have left on the stream? Like, I guess people should hop on Discord, right, and get to engage, right?
Yeah. So if you go to zmk.dev, there's a Discord link in the very bottom if you want to join our Discord and chat real time there. GitHub's there. Join us there if you want to look at all the fun PRs coming up. We're on Mastodon and Twitter less. You should be able to find
X,
us.
whatever.
Join us. Yeah. Thank you. Yeah, for sure. Join us. Come check it out. Build a keyboard. Hack on a dev kit, whatever. I'm happy to help support you here. I come to Zigbee. Zigbee
well,
stuff.
Someone actually pinged me on the side. Didn't comment on the public chat, but telling me, hey, you know what? We should keep going. I think we will wrap it up, but I'm pretty sure there will be questions for another couple hours. But feel free to take this one. Like it's. I was actually thinking that, like, especially when you're sort of like wired. Why not use the fact that you have this Wi-Fi / Bluetooth capable MCU to like run a Zigbee gateway and to have like a bunch of temperature sensors for exactly.
Yeah, do it. I would love for somebody to come do that stuff. It should totally be possible. Yes, bandwidth being what it is, I only have so much time for hacking on cool stuff. Please come do it. It should be totally doable.
But speaking of bandwidth, actually, like how far are you pushing the MCUs that you're typically using, like whether it's the Nordics or the other ones? Like, how much room is there for doing more stuff without messing up with the responsiveness of the keyboard and latency? And
yeah, that's an interesting one. So, it depends, for basic keyboards that don't have like RGB and screens and all this other stuff going on, it's pretty darn easy. The Zephyr infrastructure is really awesome to do sort of asynchronous interrupt based stuff. That's also, part of the way that we're being so low power is, a lot of existing sort of USB only firmwares, they're literally just like pull the loop, like one big loop, and it's literally just like constant polling state of stuff. And that's obviously going to kill your battery, right? And so we've laser focused on like, don't do that, interrupt based everything, right? And so we're more often not doing something than we are doing something, which is great because that's how we get great battery life, right? And so lots of room there, for folks that do push a bunch of RGB and stuff, that can be challenging at times. Displays was interesting. There's a few devices that have been made with e-ink displays, which are fabulous, but they're actually really slow. And so it turns out we can't just use our system work queue and push a bunch of display updates from our system work queue, because now our system work queue is not going to be responding to your key presses. And so that was a fun little bit of hacking where we actually got to push all of our display, updates to a different work queue, different thread, and it all just sort of worked after. And now there were some details around some threading and race condition stuff that we had to be a little bit careful with. It required some changes, but fundamentally, like with a week and a half of hacking, I could move all of our display updates optionally to a secondary work queue, do some interesting stuff around state management, and now you can have super slow e-ink display doing its stuff, and your keyboard is still perfectly responsive. Awesome. Thank you, Zephyr. Thanks. The work queue stuff enabled that pretty easily. And so, we at times push it, but it's really nice infrastructure that's in place to allow you to like offload, do threading strategies, work queues, whatever you need to do in order to solve it if you need to, because it's come up and it's been fun. So room there for sure, depending on how nasty you want to get with what you're doing. I wouldn't run Doom on your Nordic chip while you're wanting your keyboard to be low latency, but lots of room otherwise.
Awesome. Zigbee Gateway would be fun, or Matter, or whatever. Thanks from me, thanks from Christian, and I'm sure many others people who are watching the show. We will be back in 2 weeks' time with another cool topic. We're going to talk about all things robots this time around, and Dave and the team at Beechwood Software have been recently playing with Raspberry Pi Pico and ROS and Zephyr, and it's going to be interesting to see how everything fits together. There's more questions coming in the chat. I guess we will just take them offline. Guys, if you're still watching live, remember that it's recorded. Like, you can catch up if you missed the beginning, or just want to watch the thing again. It's on YouTube, it's on LinkedIn. You can add your comments, and we will make sure to send them Pete's way so that they get answered. Feel free to subscribe, to like the video. This is always appreciated. I think I put the link earlier. Feel free to reach out to me if there are things that you would like to talk on the show. Maybe, Pete, you will be back in a few weeks' time or in a few months' time, because I'm sure we could talk about this for hours. But this was really great to have you. Don't know if we woke up the kids. Hopefully not. But have a great day.
Crossing my fingers, still sleeping. I haven't got too excited here.
Have a great day ahead of you. And everyone, we will be back in 2 weeks' time. Bye.
Thanks, Benjamin.